A well-designed experiment has several characteristics, and they will ask you questions about what characteristic may be missing, or whether or not it is a well-designed experiment and why or why not. So the key to this is vocabulary. Okay, you've got to be familiar with these vocabulary terms, so they are there on your paper. I'm going to talk through a few of them. I think a treatment, you're kind of familiar with that. It's pretty self-explanatory. It's what you want to compare. So typically we think about treatments in terms of medical treatments, but that's not always the case. It's not always a medical situation. We could be dealing with something else, but it's what you are trying to see if it has any effect or not. Your response variable is the response. What happens when you give the treatment? What is the response? What happens? What's the outcome? And we measure that typically. We've got our subjects. Those could be things, it could be plants, it could be animals, it could be humans, it could be any number of things that are being tested. Here's one key, a random assignment. Okay, that's pretty self-explanatory, that you don't set it out in any specific order. You just randomly give it to all of your subjects, or some of your subjects. We have a comparison or a control group, and that's the group that doesn't change. So either we're trying to compare to just nothing, or a control is a lot of times they give them the next vocabulary word, a placebo. That's kind of a trick or a sugar pill, so to speak. Some people will kind of think that just because they're receiving a pill that they are getting better or they're feeling better or whatever. And that's what we call the placebo effect. They think they're getting the treatment, so they think they're getting better, but they're actually not getting it. And then we can have blindness in our treatments, in our experiments. Subject blind, that's when the subject doesn't know what they're being given or not being given. Evaluator blind means that the person that's trying to measure the results, they don't know. And then double blind is when both of them don't know what's going on. And then a lurking variable, we're going to talk about that quite a bit. Sometimes it explains what's going on, but it's not what your study was trying to test. Okay, so we'll look at some examples. Okay, so let's look at this first experiment. A common science experiment attempts to determine if mung bean seeds that are given a gentle zap in a microwave are more likely to sprout than seeds that are not put in the microwave for a little while. So let's talk about what the treatments are. Okay, so what is being done to those seeds? Well, they're either being put in the microwave or they are not being put in the microwave. That's the treatment, whether it's put in the microwave or not. Okay, and then the response variable is what we're trying to measure. We're trying to find out if they sprout or not. So the treatment is what we do to it. We put it in the microwave or we don't put it in the microwave. The response variable is what we are trying to measure, and that's whether it sprouts or not. Okay, so let's look at a couple of different setups for different ways that these experiments can be done. Okay. Part B says, for his experiment, Carlos zapped 10 mung bean seeds and 8 of them sprouted. Explain why Carlos should not conclude that mung bean seeds zapped in a microwave are more likely to sprout than if they had not been zapped. Well, he's missing something here. He zapped all of them. He didn't have that other treatment where he didn't zap any of them. Okay. So he cannot conclude, just because 8 out of the 10 sprouted, he didn't have anything to compare it to. Didn't have anything to compare it to. Because he zapped all of them. There wasn't that other treatment. Whenever you're doing an experiment like this, you have to have a group that you do it to and a group that you don't do it to. Okay. Part C says that in her experiment, Mia took 20, picked out 10 that looked healthy, and zapped those. Of the 10 that were zapped, 8 of them sprouted. Of the 10 that were not zapped, 3 of them sprouted. Explain why Mia should not conclude that the ones that were zapped were more likely to sprout. Well, here's the key. She picked out 10 that looked healthy. Okay, she picked the ones that looked the best and zapped those, and then the unhealthy looking ones didn't zap. So wouldn't you think if they don't look good to start with, they're probably not going to sprout? Okay, so let's just say she's got some bias. Okay, she has some bias, or it wasn't random. It wasn't random because she picked out the specific 10 that were going to be zapped. Okay, let's look at a third one. For her experiment, Julia took 4 seeds, selected 2 at random to be zapped, and zapped those 2. So she did the random thing, and both seeds that were zapped sprouted. The 2 seeds that were not zapped did not sprout, so she doesn't have the issue that Carlos had. She's got some that she put in the microwave and some that she did not put in the microwave. She doesn't have the issue that Mia had. She picked them randomly, okay? But it still says that Julia should not conclude that the seeds zapped in a microwave are more likely to sprout if they had not been zapped. The problem with Julia is she only picked 4, okay? She only picked 4. She didn't have enough. If you're just comparing 2 versus 2, what are the odds that the 2 that were selected to be put in the microwave sprouted and the 2 that were not didn't? It's pretty high chances there because you don't have much. I should be specific, not enough subjects, not enough beans. Okay, so part E says design an experiment. We want to take all the good stuff from each of these and put together an experiment that we think would be best. So, any ideas? What was good? Was there anything good from Carlos's? Anything good from Carlos's? Not really. He didn't have anything to compare it to. He zapped them all. He only had 10. Okay. How about Mia's? She took 20. She picked out 10. She zapped them. The other 10 she didn't zap. So how could we fix Mia's there? How could we fix Mia's experiment? Do you think 20 is a good number? Probably. 20 is probably a good number here. Okay. Well, what was the problem after she picked the 20? She picked the 10 that were healthy. So how about instead of picking 10 that look healthy, you randomly select 10. Okay, so I think probably Mia's experiment here is the best, but really the only thing we need to change is to randomly assign 10 beans to be put in the microwave or to be zapped. And you can do that any number of ways. You could put all the beans in a bag, shake them up, just pull out the first 10 that you grab. That's one way to do it. Or you could lay them out and do every other one or something like that. But just randomly assign the 10 beans to be zapped. And then she's pretty good. She's got 20. She just needs, and she has the 2 different treatments, she just needs that random assignment. Okay, so in a typical experiment, 2 or more treatments are randomly assigned to an available group of people called subjects. We already talked about that. The purpose of an experiment is to establish cause and effect. We want to see, does the treatment cause this result or this response? A well-designed experiment must have 3 characteristics. And we saw these in the previous problem. You must have random assignment. The treatments must be assigned randomly to the subject. You can't pick specific ones to receive a specific treatment, or you're introducing bias. You must have a sufficient number of subjects. So sometimes it's hard to decide how much a sufficient number is, but you definitely probably want more than 10 if possible. Is usually a good idea. Okay, and then you have to have something to compare it to, or something that is called a control group. A comparison group would be if you're comparing 2 different types of treatments. A control group is a group that doesn't get the treatment. Okay, a group that gets no treatment is the control group, or 2 groups that get different treatments are compared. Okay, so we have to have those 3 things in order for it to be a well-designed experiment. So we kind of already talked about this, but let's review it really quickly. Which characteristics of a well-designed experiment was or were missing in problem 1 in the mung bean study of Carlos? Well, Carlos was definitely missing the comparison or the control group. We'll say control in this case because they weren't being put in the microwave. And you probably could argue the sufficient number. You could probably argue the sufficient number as well. But the main thing with Carlos is the control group. With Mia, she was missing the random assignment. And Julia was missing the sufficient number. We don't need to worry about part B because we didn't talk about that. Let's look at part C. What can go wrong if treatments are not assigned randomly to the subjects? Well, there are a variety of things that can go wrong, but the biggest one is the term just bias. Okay? In the case of this study, if you pick the healthy beans, they're more likely to sprout anyways. Okay? If they're healthy, they're more likely to sprout. It doesn't matter whether they're put in the microwave or not. If you're talking about an experiment on people or a treatment on people, if you're talking about a certain type of medication, if you give it to this group that looks like they're doing better anyways, well, obviously that treatment's probably going to have better effects. Or vice versa. If you give it to the group that's not doing as well, it's probably not going to have as good of results. So there's a lot of danger if you don't assign treatments randomly to your subjects. All right, now here's a big thing that we have to look out for and that they will probably ask you about. A lurking variable. Okay, a lurking variable, we already talked about the vocab word. But a lurking variable helps to explain the association between the treatments and the response, but it is not the explanation that the study was designed to test. So, for example, with our seeds, the lurking variable, if you put the healthy ones in the microwave, they already looked better. They were already healthy. So that's a lurking variable. You pick the healthy ones to put in the microwave. So it may just be that they were healthier beans. They were more likely to sprout anyways. Okay, so that is one reason why treatments are assigned randomly. It's trying to take into consideration or trying to eliminate these lurking variables as much as possible. You're never going to completely get around it, but it will kind of help minimize the effects of it. Okay, so what I want you to do is I want you to read that description of that study for part A, and I want you to answer the questions there for parts 1 and 2.